Selective laser sintering, SLS, can be the low-cost additive manufacturing process, the low-cost process, period, for producing a polymer part. And I'm going to talk about that with Nate Stevens, who works with SLS every day as part of his work with Lifestyle Additive.
Hello.
And Nate, thank you for letting me join you.
Yes, thank you.
I'm Pete Zelinski. SLS could be the lowest cost process of all, but that runs contrary to expectation in some cases. SLS, Nate, is sometimes assumed to be a high cost process. Why is that, and is that fair?
I think largely there's market limitations. The materials tend to be more expensive, the equipment tends to be more expensive. SLS is not just the printing process. It's everything in this room. It's the printing, it's the cleaning, it's the smoothing. Every step of the process has to be taken into account. A lot of times their part has not been optimized for SLS printing, specifically for cost savings with SLS printing. And so that's one of the things that I try to help them understand is what little changes can we make to reduce cost in the SLS process.
If you start with a part as designed and you can end up with a process where SLS is the cheapest way to make it, what are the kinds of design choices that get you from A to B?
So I'm going to break it up into direct and indirect cost savings.
Yeah.
Direct cost savings have to do more with reducing the amount of material, reducing the amount of print time, increasing the number of parts you can put in a build. Indirect, building multiple parts in one, saving cost in assembly time. Bill of material, supply chain management. The first part of that is reducing the material used. This is a good part for that. It looks big and bulky, but it's actually very thin. The internal features give it the rigidity that we want while also minimizing the amount of material used. In addition to that, this part was much bigger. We reduced the overall size of it. With SLS, there's kind of a fixed cost with each run. If I pack that printer full of parts, it costs me the same amount to run that printer, whether there's one part or 500 parts in there. And so being able to optimize for the number of parts you can fit in the print reduces the overall cost.
And you're describing some fairly subtle changes that probably didn't much affect the experience of this part, but had a big impact on the cost.
Not hardly at all. We're talking 5 millimeters. I was able to fit 20 more parts in a build frame. It didn't really impact the function of that part.
What is a common design mistake that drives up the cost of an SLS part?
Thick walls, 100% will always drive up the cost. The laser is only, 35 microns in diameter,
yeah.
And it's having to laser that entire cross section, and it takes a lot of time. So by having thick walls, you're both occupying a lot of space, you're taking up a lot of material, and you're increasing the runtime on the machine as well.
I have heard you compare SLS nylon with machined Delrin. And can you talk about the comparison and the economics of those two means of getting at a low quantity polymer part?
Anytime you buy a block of material and cut most of that away, you've lost money. SLS, you're only using the material that you need. This part was I think like $100, $200 some odd dollars, but if we were to machine this in plastic, it would be thousands of dollars. And we're able to accomplish all of the same functions.
Because you'd have to start with a block,
yeah.
And because everything we see here that's an open space, this is just something that didn't have to be printed, whereas in machining, this is something that had to be removed.
Correct, yeah.
What is reused powder and how does that affect cost?
While you're selectively sintering the material that you need, all of that other material can be re-sieved and reprocessed and remixed to run more parts in the future. Even with resin printers, there's some scrap in that. FDM prints, all of that support material that you print to get to the part that you're trying to build gets thrown away. The majority of the powder that is unsintered can be reused.
How do different applications follow different powder reuse strategies?
It was something I'll approach customers about, especially if it's more of a consumer grade part with large, not so fine detail features, something like this. We can actually use a higher reuse to virgin powder, new powder. It has some drop off in the overall surface finish, but overall strength and material properties is equivalent to the 50-50 that is more typical. With that 50-50 mix, we get more precise parts and better surface finish.
When a build is finished in SLS, what that looks like is a block of powder coming out of the machine. All the parts are inside that block. And so removing that powder is a follow-up step. Talk about the engineering of that. How do powder escape paths affect the cost of a part?
The first time we built this part, we would spend probably 10 to 15 minutes per part just trying to poke out all of the powder. Adding these little escape holes allows the media to remove all of that powder just in the automatic tumbling process. Other little parts, when we're printing little fine detail parts, sometimes we'll add a little cage around the parts that prints around them, and we can pull that cage out and we blast all the parts off and they just stay in the cage until we're done. And
printing the cage adds nothing to the time of the build. It potentially saves a lot of time of rooting around looking for parts.
Saves us way more time than it costs for the material for that cage. So we actually printed a cork on this part. Very minimal material used, but we were able to pull on that cork and pull the majority of the powder out. We're actually saving time, which is time is expensive too.
Where do printed threads make sense relative to machine threads?
With SLS printing, we actually recommend you model the threads in to your design, because we can chase the threads with a tap after, and it's very quick. Cutting new threads is unreliable, and the plastic is so flexible that it might be cutting in one area and just stretching in another area, but modeling the threads in 9 times out of 10 is a better option.
When people compare the economics of SLS versus injection molding, what are costs that they often overlook?
When you're looking at per part cost, an injection molded part might be pennies a piece, but break out the cost of your mold. SLS allows you to build without that associated mold cost, and you only pay for the number that you order. You don't have to pay for the mold up front and order a certain number to justify the cost of that mold.
What could you say generally about where the break-even quantities land?
That 10,000 part range, but there's some caveats to that. You might build 10,000 parts and want to make a change. On the injection molding side, you might be looking at expensive modifications with SLS printing. Just send us the new file.
Are there scenarios where a part might have been conceived with an eye for injection molding, but ultimately the most cost-effective choice is to stick with SLS all the way through the life of that product?
This part in particular, in injection molding, we actually have to split that in half, whereas with SLS, you could just print it and it's done. If you're building a part and you're planning on it being a 3D printed part for the duration of its life, there are things that we can do with powder reuse ratios, with removing material, with latticing, with post-processing to allow that to stay in 3D printing for the duration of its life.
There are all kinds of variables you can play with to get to a cost target that makes sense for a production part.
Yeah, and all of that starts with consistent communication with what their targets are. There are things that we can adjust.
Parting thought on cost of an SLS part.
Don't be scared by the first price you get.
And if the cost is initially high, it's because you're drawing on the information you have available, and part of what might be missing is how much room there is to modify certain inputs.
Of all of the parts that have come across my desk, 90% of them, is always room to adjust.
This episode's part of a collection on the SLS Mindset, how to design for selective laser sintering. Check out other videos in this series.